Today we're going to talk about variables and their expressions. What we'll learn today are two objectives. One is to identify variables, numerical expressions, and algebraic expressions. And the second one is to write algebraic expressions for word phrases. Let's start with to identify variables and numerical expressions with algebraic expressions. So let's start with the question, how many miles can you drive on 10 gallons of gas? Well, different cars require have different mileage, so we need to figure that out. So let's start with the pickup truck. May get 160 miles in 10 gallons of gas. So what we're going to do is take 160 divided by 10. And that is called a numerical expression. Okay? But what if we don't know what it is? Well, we're going to have to take however many miles that vehicle gets and divide it by 10 gallons of gas. So we're going to do m divided by 10, where m is the number of miles. That is called an algebraic expression or a variable expression. And the variable that they gave you is m. Let's try example 1. Let's identify expressions. Identify each expression as a numerical expression or an algebraic expression. If the expression is an algebraic expression, name the variable. So letter A, 5 minus 5. I don't see any variables, so that would be a numerical expression. And we don't have a variable, so we cannot identify it. Let's go to letter B, C minus 5. That has a variable, so that is an algebraic expression. And the variable is C. It is now your turn to check your understanding. Now let's move on to our second objective, which is to write algebraic expressions for word phrases. I have on the screen a few examples of what they could look like. I have given you a word phrase and an algebraic expression. I've also given you some vocabulary tips on the right for words that would mean if you would add them, subtract them, multiply them, or divide them. So let's look on the left. It says 9 more than a number y. Well, 9 more than fits right up here as an addition sign. So notice they did y plus 9. 9 plus y would also be acceptable. 4 less than a number n. Well, 4 less than a number, that would be subtraction. But you want 4 less than a number, so the n needs to go first, n minus 4, which is different than 4 minus n. A number z times 3 can be shown many different ways. We are going to start using this 3z idea with no dot in the middle. The parentheses will be used for more complicated things, but this is the one we'll be using the most. A number a divided by 12. In division, it goes in the order it's given to you, so A is listed first, 12 goes second, so A is on top, 12 is on bottom. This is the way that we'll use it this year. This is acceptable, but this is what we're going to be shooting for. A new one for you might be 5 times the quantity of 4 plus a number c. So when they say the quantity of, that means you need parentheses in. So I would recommend using this one, since we're trying not to use this dot anymore. So this means parentheses first, and then multiply by 5. Now, let's try that one with an example. Writing an algebraic expression. The maximum speed allowed in a solar car race is 65 miles per hour. Write an algebraic expression for the distance a solar car could travel in a given time at an average speed of 65 miles per hour. So we're going to start with using a formula we're going to use throughout all of your high school career in a math and science. Distance equals rate times time. Let's start off with what we know. We don't know the distance, but we do know the rate, and we don't know the time, so we're going to use 65t for an expression. Now, let's check your understanding.